Good day, listeners. Today, I will teach you some topics under integral calculus. These topics are the following: the fundamental theorem of calculus, the integral version, how to integrate exponential function using U substitution, how to integrate logarithmic functions using U substitution, and how to integrate trigonometric functions using U substitution. First topic for today will be the fundamental theorem of calculus. The formula goes like this: the integral of f of x dx as a to b. That will be equals to capital F of x evaluated from a to b. That will become capital F of b minus the capital F of A. Let's have an example. Example number 1. The integral of x cubed minus x squared from 0 to 2. The first thing we need to do is to find the antiderivatives of x cubed and x squared. That will become x raised to 4 over 4 minus x raised to 3 over 3, evaluated from 0 to 2. Then, we substitute 2 to the x. 2 raised to 4 is 16 over 4 minus 2 raised to 3 is 8 over 3. Minus, substitute 0 to the x. 0 raised to 4 is 0 and 0 raised to 3 is 0 is equals to 0. This will become our capital F of B minus our capital F of A. That will become equals to 4 over 3. Here is our answer. Example number 2. The integral of t squared minus t raised to 21 dt as negative 1 to 1. Become equals, again, find the antiderivatives of these two, t3 over 3 plus t raised to 22 over 22, evaluated from negative 1 to 1. Substitute 1 to t is equals to 1 raised to 3 over 3 plus 1 raised to 22 over 22. Minus, substitute negative 1 to t. Negative 1 cube over 3 plus negative 1 raised to 22 over 22. This is equals to 1/3 plus 1 over 22 plus, since negative 1 cube is positive times negative, it will become positive. The answer here is 1/3, then minus 1 over 22. Negative 1 over 22 and positive 1 over 22 will be cancelled. 1/3 plus 1/3 is equals to 2 over 3. And here is our answer. Our next topic is how to integrate exponential function. We will use e raised to negative x as our exponential function, and you will use u substitution, where u is equals to our exponent, which is negative x, and du is equals to negative 1 dx. Let's have an example. Example number 1. The integral of x cubed e raised to 2x to the 4th dx. We will let u equal to the exponent, the 2x raised to 4, and the du be equals to 2, bring down 4, x minus 3 dx. This is the power rule. Is equals to 4 times 2 is 8 x cubed dx. To find du, we will divide both sides by 8. cancel 8, du over 8 is equals to 8 cubed dx. Now, we will be using the integral of e. We will now substitute u to 2x raised to the 4th. And then, the dx will become substituted to du over 8. The x cubed here and here will be cancelled. Now, we will put the constant 1/8 outside. The integral of e. Now, we will be putting the 2x raised to the 4th again in place of u. Then, add the constant. Here is our answer. Example number 2. The integral of 3 plus e raised to 2x over e raised to x dx. Since they have the same denominator, it can be like this. The integral of 3 over e raised to x plus e raised to 2x over e raised to x dx. Since it's in this form, we can use the negative exponent. That will be integral of e raised to negative 3x dx, since we need to distribute it here, and e raised to 2x over ex is equals to the ex dx. Now, we will let u equals to negative 3x. And our du equals to 3 dx. To find dx, we will multiply both sides by 3. Now, our dx is equals to du over 3. Now, we will be using the formula, the square root e. Now, we will substitute the u, and the dx will become du over 3 plus e raised to x dx. We will put aside 3, then integral of eu du plus e raised to x dx. Again, 3 integral of e. We will now be using the negative 3x again to substitute in u. Then the du will become the dx plus the e raised to x dx is equals to ex. Now it will become 3 e raised to negative 3x plus ex, and our dx will become the plus c constant. In integrating logarithmic functions, we will use the formula ln of u dx. Now, always add absolute value because we can't have negative logarithmic function. Example number 1. The integral of 1 over x plus 7 dx. The answer here is ln of x plus 7 plus c. I will show you how did I get the answer by using the u substitution. We will now let u be equals to x plus 7 and du equals to dx. Now substitute 1, the integral of 1 over u du is equals to ln of u plus c. Now, substitute the u to x plus 7 and put the absolute value plus c. Here is our answer. Example number 2. The integral of 10 over 5 minus 5x dx. We will let u be equals to 5 minus 5x and du equals to dx. this is equals to 10 over u du, and ln of u plus c is equals to 10 ln of 5 minus 5x plus c. Now we will find the derivative of u, which is negative 5, and we will use that to divide the numerator 10, which is negative 2. Then just copy plus c. Here is our answer. Now we will be discussing about how to integrate trigonometric functions. But first, we need to remember these formulas. Sine squared plus cosine squared is equals to 1. 1 minus sine squared x equals to cosine squared x. 1 minus cosine squared x equals to sine squared x. 1 plus tangent squared x is equals to secant squared x. 1 plus cotangent squared x is equals to cosecant squared x. Now, we also need to know some double angle identities, like sine times 2x is equals to 2 sine x cosine x, and cosine times 2x is equals to cosine squared x minus sine squared x. Can also be equal to 1 minus 2 sine squared x and 2 cosine squared x minus 1. If you want to find the sine x here, that will be equals to 1/2 1 minus cosine 2x. And if you want to find the cosine squared x here, it will be equal to 1/2 1 plus cosine 2x. Example number 1. The integral of sine cube x dx. Since we have an odd power, we will be dividing it into 2. That will become the integral of sine squared x sine x dx. So, we know that sine squared x is equals to 1 minus cosine squared x, then sine x dx. We will let u be equals to cosine x and du equals to sine x dx. To find dx, we will divide both sides by sine x. Sine x will be cancelled. Dx is equals to du over sine x. Now, we will be substituting the u. Integral of 1 minus u squared sine x. The dx will be du over sine x. Sine x will be cancelled. Now, we will find the antiderivative of 1 and the u squared. The antiderivative of 1 is u minus the antiderivative of u squared is u cubed over 3 plus the du, which is the c. Then, we will substitute again the u to its original form. It will be cosine x minus cosine cube x over 3 plus c. Here is our final answer. Sample number 2. The integral of secant raised to 5x dx. See, again, it has a odd power, so we can be divided it into secant to the 4th x secant x dx. And we can again divide secant 4x into 2, which is secant squared x and another secant squared x. Secant x dx. Now, these two can be written as secant squared x squared secant x dx. Now, we all know that secant squared is equals to 1 plus tangent squared x squared secant x dx. Now, we will use the u substitution. We will let u be equals to tangent x and du is equals to secant x dx. To get dx, we will divide both sides by secant x. Cancel. Dx is equals to du over secant x. Now, we will be using the substitution. 1 plus u squared then secant x dx will be changed to du over secant x. Secant x will be cancelled, and then these two can be written as 1 plus u squared and another 1 plus u squared du. So we will use FOIL method in these two, which will be the integral of 1 plus u squared plus u squared plus u to the fourth by using FOIL method. Then du. We will combine the like terms, and that will become 1 plus 2u squared plus u to the fourth du. Then find the derivatives of this. That will become equals to, find the antiderivative of this function, which is the antiderivative of 1 is u, plus the antiderivative of 2u squared is 2u cubed over 3 plus u to the fifth over 5 plus c. So, replace u will become equals to tangent x plus 2/3 tangent cube x plus 1/5 tangent raised to the 5 x plus c. This is our answer.